welcome to my class. In this particular session, we will talk about virtual memory. The term virtual refers to something which appears to be real but actually it is not. The term virtual memory refers to that memory in the computer which appears to the user as real but actually it is not there. The virtual memory technique allows a user to use more memory for a program than the real memory of a computer. So virtual memory is the concept that gives the illusion to the user that they will have main memory equal to the size of secondary storage media. Here two things are very important. What is main memory and secondary storage media? Main memory means the primary memory, which is RAM. Secondary storage media means the memory space on the hard disk. Virtual memory is an area of a computer system's secondary memory storage space, such as a hard disk, which acts as if it were a part of the system's RAM or primary memory. So virtual memory is an area on the hard disk which acts like a RAM. When a particular data or program is to be processed by CPU, that data or program is brought inside the RAM by operating system. CPU, for the purpose of processing data, fetches it from RAM. After processing the data, the CPU returns the result to RAM. In other words, RAM stores the raw data before processing by CPU and RAM stores the finished processed data after processing by CPU. If data or program which needs to be processed is in the RAM, the CPU directly accesses the data or program from RAM. The execution, that is processing, the processing of the task becomes faster. If data or program which needs to be processed is not in the RAM, then operating system looks for data or program from hard disk. The operating system shall first search the hard disk and then copy that data or program from the hard disk and brings it to the RAM. This process slows down the performance of computer as CPU has to wait for the data or program. It means that if the RAM size is big enough, then it can store more programs and data which can be directly accessed by CPU. The processing by CPU becomes faster because CPU need not wait for the data program to be processed as it is already in the RAM. The whole discussion suggests that RAM size should be very big, but we should not forget that RAM is an expensive memory. Ideally, the data needed to run application is stored in RAM where they can be accessed quickly by the CPU. When large applications are being run or when many applications are running at once, the system's RAM may become full. Because our computer has a finite amount of RAM, it is possible to run out of memory when too many programs are running at one time. So what is to be done? Solution is virtual memory. Here some data stored in RAM that is not actively being used by CPU can be temporarily moved to virtual memory area which is physically located on a hard disk. This frees up some space in RAM which can then be used to accommodate fresh data program which the CPU needs to access immediately to continue processing. Let's look at this particular example. We have main memory, that is RAM. This particular RAM has a capacity to hold only 6 pages. Just assume it that it has the capacity to hold only 6 pages. On the other side, we have secondary memory, that is hard disk. It has a huge space. The hard disk has big space. Now, CPU needs to process A, B, C, D, E, F page, but RAM is full. No more pages can be accommodated inside the RAM. So what is to be done in this case? The operating system will swap out these G, H, I, J, K, L pages to hard disk. Now the RAM is free. Operating system will swap in A, B, C, D, E, F pages inside the RAM. Now the processor can start working. It means operating system has performed two jobs. One is swap in, second is swap out. When it takes data out from RAM to hard disk, it is swap out. When it takes data from hard disk to main memory, that is RAM, then this is termed as swap in. Look at this particular example once more. Now the CPU requires MNOPQR pages, but the RAM is full. It does not have the capacity to hold more pages. So what the operating system does, operating system will swap out A, B, C, D, E, F pages from RAM to hard disk, and operating system will swap in MNOPQR pages to RAM. Now the CPU can start processing over these pages. Here again two processes are involved. One is swap in, second is swap out. In this way, the main memory, that is RAM size is fixed, but we can make use of size equivalent to the size of hard disk by making use of two processes, swap in and swap out. That is why it is said that RAM size becomes equivalent to the size of secondary memory. In reality it is not there, but it appears that the size of the RAM is equivalent to the size of hard disk. That is why we call it this particular thing as virtual memory. In this way, the operating system can take out inactive data not immediately required by the CPU from RAM and place it in the hard disk. It is termed as swap out. And the data which is on the hard disk and urgently required by the CPU for the purpose of processing, the operating system copies it from the hard disk and brings it to the main memory, that is RAM. This is termed as swap in. Though the RAM size is small, swapping in and swapping out process by operating system eliminates the deficiency of RAM size. It gives the appearance to the user that RAM is of big size, whereas in reality it is not. That is why it is named as virtual memory. Therefore, the RAM size becomes apparently equivalent or equal to the size of hard disk. However, since the hard disk drive is much slower than the RAM, the data stored in virtual memory of the hard disk must be mapped back to real memory, that is RAM, in order to be used. The process of mapping data back and forth between the hard disk drive and the RAM takes longer time than accessing it directly from the main memory. This means the more the virtual memory is used, the more it will slow down the performance of computer. In simple words, too much of swapping in and swapping out of data from RAM to hard disk and vice versa, it consumes more of the operating system time and efficiency, which may result into degenerated performance of the computer system. While virtual memory enables our computer to run more programs than it could otherwise, it is always better to have bigger RAM size. This allows the computer to run most programs directly from the RAM, avoiding the need to use virtual memory. Having more RAM means computer works less, making it a faster machine. Now let us look at the summary of virtual memory. Virtual memory was developed at a time when physical memory, that is the installed RAM, was very expensive. Computers have a finite amount of RAM, so memory can run out, especially when multiple programs run at the same time. The operating system using virtual memory uses a section of the hard drive to emulate RAM. With virtual memory, a system can load larger programs or multiple programs running at the same time, allowing each one to operate as if it has infinite memory and without having to spend more money for bigger RAM. Virtual memory is a memory management capability of an operating system which uses hardware and software to allow a computer to compensate for deficiency of physical memory by temporarily transferring data from RAM to hard disk storage. Virtual memory space is increased using active memory in RAM and inactive memory in the hard disk drive. Thank you very much.